Alright, special right triangles 45, 45, 90. Our pattern is x, x, and x root 2. That means if you know one of the legs of the right triangle, one of the numbers opposite from the 45 degree, then you can find them all very easily with this nice little pattern. So, for example, here we see 4 is across from one of the 45 degree angles. That means if I were to write this angle in, this is 45, because what else could it be? Because 45 plus 45 is equal to 90. That 4 is opposite of my 45 degrees. That means that 4 goes here. That means if that x is 4, this x is 4, and this is 4 root 2. You can write them over here. So that means y is equal to 4, and x is equal to 4 root 2. This x and y are not really the same as this. This is just to help us for a pattern. You can use any variable here. So let's look at another one down here. A little bit different, this time across from the 90. So we have 45, 45, 90. X, x, and x root 2. Where does that 10 root 2 go? It goes across from the 90 degrees. So we get 10 root 2. And we notice, hey, this time, look how our x matches right up. The root 2 matches, so the x must match. That means this is 10. That means this is also. So that means y is equal to 10 and x is equal to 10. So this is a 10 right here, and that's a 10 right there. 10, 10, 10 root 2. What else might happen here? You might have a radical number across from one of the 45. So we think 45, 45, 90, x, x, and x root 2. So this time, across from one of those 45s is 4 root 2. So if this is 4 root 2, and this is 4 root 2, that means we have to take this and replace it for x. I didn't draw that very well. Let me look at this again here. Okay, so this is supposed to be a 4 root 2. 4 x root 2. What am I talking about? Erasing. 4 root 2 is down here. So this is supposed to be x root 2. That means we're going to take this 4 root 2 and replace it just for this x right here. So it's going to be a little interesting math problem that starts like this. It's going to be 4 root 2. That's my x. And then the root 2 that was still there. But if we know how to multiply these radicals, it shouldn't be too bad. We know the square root of 2 times the square root of 2 is just 2. So this is just 4 times 2. That makes 8. So what does that mean? That means that our sides of our right triangle are 4 root 2. This is going to be the same. 4 root 2. And down here will be 8. 4 root 2, 4 root 2, and 8. Because if you take 4 root 2 and multiply it by the square root of 2, you get 8. What do the harder problems look like here? Type 3, hard. Alright, 45, 45, 90. X, x, x root 2. Where's this 4 going to go? It's across, or opposite from, the 90. So that's a 4. So we end up with a little equation here. We end up with x root 2 is equal to 4. How do we solve for x? We got to divide both sides by the square root of 2. And so we get a number 4 over the square root of 2 that you have to rationalize. We got to multiply top and bottom by the square root of 2. So we end up with this strange looking number. Those will cancel. So we just got x is equal to 4 root 2 over 2. Then we can do some classic math like reducing a fraction here. Really we're just dividing this 4. Can be divided by 2, leaving you with x is equal to 2 root 2. So that means this is 2 root 2, and this is 2 root 2. 2 root 2, 2 root 2, and 4. 45, 45, 90. Let's do one more like that. 45, 45, 90. X, x, x root 2. That 5 is opposite from the 90. So that 5 is going to go right there. So we set up our same equation. X root 2 is equal to 5. X root 2 is equal to 5. How do we solve for x? We divide both sides by the square root of 2. And then this will cancel. We have to rationalize, multiply top and bottom by the square root of 2. That's always going to be the same. We get 5 root 2 over 2. Can't reduce that. I don't want any 2.5 root 2 or any of that nonsense. We have to keep this as whole numbers best we can. So there's our x. That means, for the sake of this problem, on a space here, but that means a, this part, is 5 root 2 over 2, and b is the same, 5 root 2 over 2.